Within a procedure, you can use control structures to alter the sequential execution of instructions. The most basic control structure is the if statement. This control structure tests one or more expressions and conditionally executes at most one block of statements. This control structure first tests the condition to determine if it is true or false. It is considered true if the value is not equal to 0. If the value is 0, then it is considered false. If true, then the if statements are executed and the remainder of the statements down to the end if are skipped. If false, the if statements are skipped and the first else if or else, if present, is processed. If an else if clause is present, its else if condition is tested and, if true, the associated else if statements are executed, after which execution continues after the end if. Otherwise, the else if statements are skipped and the next else if or else is processed. If all conditional tests fail and an else is present, the else statements are executed. An if then can contain several or no else if clauses. If present, these must be specified before the optional else clause. The for control structure executes a sequence of instructions a fixed number of times. This control structure begins by setting the variable to the initial value. The variable can be any numeric type like a byte, integer, short, single, or double. Array variables as well as object and structure fields are also permitted. However, object and structure properties are not permitted. If the initial value does not exceed the final value, the loop statements are executed once. However, if the initial value exceeds the final value, the loop statements are skipped and execution continues at the statement following the next instruction. If the loop statements are executed, execution proceeds until the next instruction is encountered. When the next statement is executed, the increment is added to the variable and its value is compared again to the final value. So long as the final value is not exceeded, the loop statements are executed again and the process is repeated. The initial value, final value, and increment can all be arbitrarily complex arithmetic expressions. However, these expressions are only evaluated when the for statement is executed and their values are saved for use by the next statement. Therefore, if the values of these expressions change during the execution of the for loop, it does not alter the saved values. Since these expressions are only evaluated once, the for loop is generally more efficient than other looping methods. The increment value is optional and can be positive or negative. If positive, looping terminates when the variable's value is greater than the final value. If negative, looping terminates when the variable's value is less than the final value. If not specified, a value of 1 is assumed. The for loop can be prematurely terminated by executing an exit for statement or a Goto statement that branches outside of the for loop. The while statement tests a condition and, if true, executes a block of statements repeatedly until the condition is false. This control structure begins by evaluating the test expression. If the expression value is true, the block of statements is executed. When the end while is encountered, the test expression is evaluated again. If the test expression is still true, the while statements are executed again. This sequence is repeated so long as the test expression remains true. As soon as the test expression tests false, the while statements are skipped and execution continues at the statement following the end while. If the test expression is false when the while begins execution, the statements are skipped and are not executed. The while loop can be terminated before the conclusion of the while statements by executing an exit while statement or a Goto statement that branches outside of the while loop. The do loop statement bounds a block of instructions that are repeatedly executed so long as a specified expression evaluates to true or until the expression value becomes true. The condition being evaluated can either appear at the start of the block immediately after the do keyword, or they can appear at the end of the block immediately after the loop keyword. The evaluation has two different variations. The first is a while check and the second is an until check. The select statement executes one of several blocks of statements based upon matching a numeric or string expression value. This control structure is similar to the if and else if statements in that a series of values are compared to determine the statements that are executed next. However, this control structure is more efficient and convenient than a series of if statements if a single value is to be compared to multiple possible values. The match value is evaluated once and then sequentially tested against each test expression specified in a series of case statements. When a matching test expression value is found, the associated case statements are executed. Following the execution of the appropriate case statements, execution continues at the statement following the end select. If no test expression is matched and a case else is present, the else statements are executed. If no test expression is matched and a case else is not defined, none of the case statements are executed and execution continues after the end select. The match value can be a general numeric or string expression and can evaluate to any of the basic arithmetic data types or a string type. Any number of case statements can be included. Each case statement can be followed by one or more numeric or string test expressions. If a test expression does not match the data type of the match value, the expression is automatically converted to the appropriate type. The last control structure is the Goto statement. It is not recommended that this be used, but it is available. This instruction executes an unconditional branch and continues execution at a specified labeled statement. A label must either conform to the conventions for a variable name or an integer literal like 100. To label an instruction, the label is placed first on the line followed by a colon followed by any standard instruction. In general, Goto instructions can make programs more difficult to understand. So, whenever possible, other control structures should be used in place of Goto.